Hello, and today we're going to be talking about human factors. Now, I know it says pharmaceuticals on this introductory slide, but believe me, it applies no matter what industry you're in. So this is a quick outline of what we're going to cover. We're going to be raising some points to think about, talk about how, as human beings, we're always going to err, look a little bit about perception and the way that we perceive things, look at our own limitations and some contributing factors for when things go wrong. And then we're going to talk briefly about the sorts of things that might make matters worse and what could make things a bit better. And we're going to go through a quick summary and right at the end are some references and acknowledgements. So no matter what we're doing, we might be innovating, distributing, we might be doing some systems modelling. We may be putting in some measures to safeguard against counterfeiting and a number of other activities. But there is always a common thread running through everything, and that is the people who come up with the ideas, interact with the equipment, the systems and the processes. Now, of course, the way we are as humans needs to be understood and taken into account if our operations are truly going to be excellent. So in our talk today, we're going to get thinking about what it means to include human factors in our daily work lives. Consider then, can I believe my eyes? Well, once upon a time, I thought I could trust my brain. I was a great fan of magic shows, and I used to sit there and, wow, willing volunteer going up to be hypnotised for our entertainment, and they did these silly things, and I thought, I wouldn't fall for that, I'm not that suggestible. And then I had the opportunity to observe and then try out a virtual reality game. To start with, I was observing on a computer screen while someone else played the game. I was told the gamer was throwing sticks for a dog. So I looked at the screen and I saw what looked similar to the Lake District. Sure enough, there was the gamer playing with a border collie, fur flowing in the virtual breeze. I was impressed, and I couldn't wait for my turn. And then it was my turn. Oh my, what a shock. Well, the background was wonderful. It still looked an awful lot like the Lake District. But there was something not quite right about that dog. And it didn't look like the lovely running collie we see in the picture below, but it did look like the animal above it, the robot dog. And it was the robot dog running around the Lake District that I was now throwing a virtual toy for. There was no flowing fur. It was black and white. And what interested me was thinking my brain had put into my head what it expected from a black and white dog having a game of chase. But the reality was quite different. So let's consider that further. Now, we all strive to achieve excellence in our particular field, and we can spend a lot of time and effort rolling out training packages and workshops. We've implemented the system, or the machine, or the process. It's refined and beautiful. So how often do we find we throw our hands up in exasperation when a human error derails our best laid plans? To err is human, so we are at a disadvantage when we're not interacting with each other and the natural world. We have evolved to cope with a natural environment, and interacting with each other was a vital part of this. In fact, so well has this happened that language itself, both spoken and body language, provides instinctive correction mechanisms. But now we need to interact with machines. a lot. Machines which lack these sophisticated systems. We might push the wrong button, move the wrong switch, and chaos may be the result. Let's think a little bit more about error and think, first of all, is what we've seen really human error? We have limitations that are fundamental to our behaviour and our psychology. There can be contributing factors, and there are other things that can make error more likely or less likely. So let's think about some of these next. First of all, let's go back to perception. I mentioned earlier on about it being suggested to me that I was going to see a dog, and my mind had conjured up a beautiful collie, when in fact the reality was quite different. So let's take a quick look at this. What do we see at first glance? Just taking a quick glimpse at that picture on the right. And now just adjust your focus a little bit. What can you see? Does it look slightly different? I'm not going to give you the answer here. Maybe we can talk about it at the end. But you can see two things. How about this then? Again, on first glance, what are we seeing? And then just as we adjust our focus a little, can we make out something slightly different? So when we look at perception, we need to bear in mind that it's subject to interpretation. Our brain responds to clues, and sometimes those clues are ambiguous. So what we see may, in fact, not be what's really there. And that's an important thing to bear in mind in the workplace. Is it really human error then? So if we are going through and we've had an event, someone might come along and say, oh, wow, I know, that was human error. But before we focus on the person, let us understand whether that error isn't actually somewhere else. So in our drawing here, we see a poor old soul taking a nasty fall. But why did that happen? Were they clumsy, not looking where they were going? Maybe the steps were slippery. But then why? Was there no wet stairs sign at the top? So we didn't know to take greater care. Maybe there were no wet stair signs. Maybe they had all been used somewhere else. But why? Maybe because all the stairs were being cleaned at the same time. So maybe we should, rather than saying it was a human error, we need actually to get more wet stair signs or don't clean everything at the same time. You can see how this develops once we broaden what we're looking at. Let's think next about some limitations around human behaviour. So let's take attention to begin with. Now in the workplace, we can get overloaded with huge quantities of information, much, much more than we would do in the natural world. And attention on a task can only be sustained for a fairly short period, depending on what it is. Now, the usual figure cited is 20 minutes, after which fatigue sets in and errors become more likely. Then we have perception. Now, for us to interact safely with the world, we need to perceive it correctly. And we've just seen how perception can get manipulated. Now, work environments in particular can challenge our perception systems, and information may be misinterpreted. Then we have memory. Now, our short-term memory is very limited, and there can be excessive pressure to access it. Now, our capacity to remember and the methods we use to access that information can put this undue pressure on us. But increasing knowledge about a subject or a process allows us to retain more information that relates to it. And then last of all on this slide, we think about logical reasoning. Now, humans are actually not very good at thinking logically, but in technical situations, logical processes are often very necessary. So what are some contributing factors? Well, I just mentioned understanding. When we understand, we link into a powerful form of internal memory. And people work best when they understand the reasons and interpretations of events. And this helps both learning and memory. We have constraints. There are limits that force certain series of events. So when we think about something called mapping, which is a technical term meaning the relationship between two things. So when we have good mapping, it's very, very helpful. An example might be steering a car. There are two mappings here. Which of over 100 controls is used to steer the car and the direction to turn it? Visibility then. Things need to be seen. And when they can be seen and the structure is obvious, it helps understanding. And then feedback. Sending back information about what action has been done and what its result is can avoid errors. Okay, so there are a number of things that we can do, some of which might make matters worse and others that might make things a lot better. So let's start with what's not going to help us very much. Well, one of the things that can really be unhelpful is for requirements to be invisible. So what does that mean? Well, there might not be any hints to the operations that are expected, or there might not be any feedback, or it might be too little. So why are these important? Well, you'll probably be aware of this in yourself. I know I am. Is that we can construct what's known as a folk psychology. That means we project our own rationalizations and beliefs onto the actions and beliefs of others. That includes machines and systems we might be interacting with. However, belief and behavior are very complex, and each individual is in no position to discover all relevant factors. So over-reliance on this folk psychology leads to assumption and can result in confusion in others. Then we've got random or non-obvious instructions. And you can maybe think about what that means, but basically it's a randomization of the interaction between what you're doing and what actually happens. And then, of course, inconsistency. So constant changing of rules, again, will make it very much more difficult for people to do things appropriately and well each time they need to do it. So here's a few other things that don't help. If a colleague has, say, done something incorrectly, if we are treating accidental actions as a breach of contract and snarl, insult, mumble unintelligible things, it's not going to help very much. If operations are dangerous, so that a single error can destroy valuable work or create a malfunction, is a design issue. And allowing it to be easy to do disastrous things, but say, put warnings in a manual so the person can be blamed for not reading it, is, again, very unhelpful. So while we're thinking about the sorts of errors people make, it's useful to consider the two common error forms. And these are slips and mistakes. Now, slips result from automatic behaviour. Mistakes will result from conscious deliberations. Now, if you are investigating a situation, slips are relatively easy to discover by simple observation and monitoring. Again, of course, that's going to need good feedback. Mistakes then can be major events and actually can be much more difficult or even impossible to detect. And when different actions have similar descriptions, there is a good chance of mishap. Interestingly enough, this can be particularly the case if the person doing those actions is experienced and very well practiced, because they might not be paying full attention and there are more important things to do. So in that situation, if we look at our top there and we are impolite, it's just going to make matters worse. So what can we do that might improve things? Now, a lot of this is to do with good design. The good design will help reduce the risk of a slip or a mistake made by the person using the machine, the system, or the process. So if we look at the bullets here and on our next slide, we're going to identify some key elements of good design that take into account the limitations of people's interactions with the environment. So we have physical mappings, logical mappings, and down the bottom we see forcing functions and natural mappings. Let's talk about that a little bit. A good example of a forcing function is the microwave. It cannot be run to cook food without the door being closed. The machine will simply not work unless we close the door. That means it's impossible to do anything else. But taking a systems approach by changing the conditions under which people work can help accommodate the fact that people are always going to make an error at some point in time. So here's a few more things to think about. It's a really good idea to narrow the gap between performing a task and evaluating it. For example, if we're at home and we flick the switch, the light comes on immediately. I can see immediately if my action has had the desired effect, but also if it has had an undesired effect. Maybe the light fails to come on. I now know immediately I need to put in a new bulb. And we should try to prevent slips before they occur, detect and correct it when they do. There is no substitute when we develop something for interaction and study of the individuals who will use a system, a thing, or a process. And while we can reduce the likelihood and consequence of error, people are always going to make some mistakes. So it's always a good idea when looking at these things not ever to punish, to take offence, but whatever you do, you mustn't ignore it. Well, and there we are, everybody. Thanks very much for listening with us today. And here are a few references and acknowledgements. I just want to draw your attention to a few of these supporting pieces of information because they are very interesting reading. So there's just a few I would like to point out. The first of these is a very interesting book, The Design of Everyday Things. I would recommend you have a read of that. There is a very interesting piece of information that is called The Belief in a Just World, A Fundamental Delusion, Perspectives in Social Psychology by Melvin J. Lerner. So that's a very interesting read. And Human Error Models and Management by Jay Reason, who's from the Department of Psychology at Manchester University. But do have a read of all of these that I've highlighted here. I'm sure you'll find them all very helpful and very interesting indeed. Okay, well, that's us for today. So thank you very much for attending. And if you've got any questions, do feel free to ask. Thank you.